After defining the solution of, after finding the solution of linear equation, now we have Bernoulli's equation, which is part of linear equation, because an equation in which is in Bernoulli's form can always be reduced to a linear form. So the equation of the form dy dx plus py is equal to cubed y to the power n, where p and q are functions of x alone or are constants, is known as Bernoulli's equation. So an equation of this form dy dx, in linear form we have dy dx plus py is equal to q, is called a linear equation, whereas Bernoulli's equation, an equation of the form dy dx plus py is equal to q times of y to the power n, where p and q are functions of x alone, is called a Bernoulli's equation. And how to reduce this? It can be reduced to linear form, means you can reduce it to the form of dy dx plus py is equal to cubed only. And for that you have to divide this equation 1, dividing 1 by y to the power n, we get. So if you divide this equation 1 by y to the power n, you have 1 by y to the power n into dy dx plus p by y to the power n into y is equal to cube of y to the power n by y to the power n. This can be cancelled. So, or you can write here y to the power minus n into dy dx plus p into y to the power 1 is this. When you bring this to the numerator, it becomes y to the power 1 minus n is equal to q. So how to express this in linear form? For that is how to express it in this form, dy dx plus py is equal to q. For that we substitute, put y to the power 1 minus n is equal to v. And when you differentiate this with respect to x, you get 1 minus n into y to the power 1 minus n minus 1 you will get into dy dx. You differentiate this with respect to x is equal to dv dx. Or you can write here, this 1 and minus 1 can be cancelled. So you have 1 minus n into y to the power minus n into dy dx is equal to dv dx. Now you substitute it in equation, this is equation 2. So therefore 2 implies now, or 2 becomes y to the power minus n into dy dx here, or okay, I'll write here, or y to the power minus n into dy dx is equal to 1 by 1 minus n into dv dx. So therefore equation 2 reduces to y to the power minus n into dy dx is nothing but 1 upon 1 minus n into dv dx, and then plus p. And what is y to the power 1 minus n? We have to replace it by v, so you replace it by v equal to cubed. Or you can write here dv dx. You multiply both sides by y to the power by 1 minus n here, so that 1 minus n from the numerator will get cancelled with this, and whereas here it will remain as pv into 1 minus n is equal to 1 minus n into cube, which is in linear form. That is dy dx plus py is equal to cubed, where p here, this p here in this case, it is p times of 1 minus v. You treat y as v now, and then x and cubed here as this cubed here is equal to 1 minus n into cubed, and can be solved by the method of linear equation. So let us see the one example how we solve this Bernoulli's equation. So you have here dy dx plus y by x is equal to y square. So what we have to do is reduce it to the form of linear form, that is dy dx plus py is equal to q. So for that you put, dividing both sides by y squared. The first step is you divide throughout this equation by y squared. What you get is y to the power minus 2 into dy dx plus 1 by x into y to the power minus 1, because y by y squared gives you y to the power minus 1 is equal to 1. Now the method is you put y to the power minus 1 is equal to v. So on differentiating this, you'll get minus y to the power minus 2 into dy dx is equal to dv dx. So therefore this equation, now name it as equation 1, therefore 1 reduces to minus y to the power minus 2 here will give you minus dv dx, and then plus 1 by x into v is equal to 1. Now I want to remove this minus from this, and for that I have to multiply throughout by minus sign, so this becomes dv dx, and here plus will change to minus 1 by x, or I can write it as plus of minus 1 by x into v is equal to minus 1, which is of the form dy dx plus py is equal to cubed, where p here is equal to minus 1 by x and cubed is equal to minus 1. Now integrating factor here will be equal to e to the power integral minus dx by x, which is equal to e to the power minus log x, which is equal to log e to the power log of x to the power minus 1, which is equal to 1 by x. Now multiplying both sides of this equation, of the given equation, that is this one, okay, you multiply it by this integrating factor, that is 1 upon x. What we get is v into 1 by x, the left hand side will always be v times of the integrating factor, minus what is cubed here, it is minus 1 into 1 upon x dx plus c, or you can write here v by x is equal to minus log x plus c, or what is v in terms of x? V in terms of x will be 1 by y, so this will be equal to v by x into x, because x is there, so v here is equal to 1 by y, so this is equal to minus log x plus c, or you can write here 1 by y is equal to minus x log x minus plus c times of x, or you can say that y here is equal to 1 divided by x log x plus cx, which is same as 1 upon cx minus x log is the required solution. I hope it is clear to you what is Bernoulli's equation. So first of all, what is Bernoulli's equation? An equation of this form, dy dx plus py is equal to cube times of y to the power n. How to reduce it to linear form? You divide both sides of this by y to the power n, so then it becomes this one, y to the power minus n dy dx plus py into 1 minus to the power 1 minus n is equal to cube. And now we want to reduce it to linear form, that is to this form, dy dx plus py is equal to cube. What we need to do is put y to the power 1 minus n as v, differentiate it with respect to x, so you will get this thing. After differentiating, then equation 2 reduces to 1 by 1 minus n into dv dx plus pv is equal to cube. And from there, this is in cross multiplied, multiply both sides by 1 minus n, so therefore it reduces to dy dx plus pv into 1 minus n equal to 1 minus n into cube, which is in the form of dy dx plus py is equal to cube. So example, you have this, you divide this both sides by y squared, so it reduces to this form, minus dv dx plus 1 by x into v equal to 1. So in order to remove this minus sign, I have to multiply throughout this by minus, so therefore it is of the form dy dx plus minus 1 by x into v is equal to minus cube, which is of the form dy dx plus py is equal to cube, where p is equal to minus 1 upon x and cube is equal to minus 1. So integrating factor, we know according to the formula, it is equal to e to the power integral p dx by p dx, but p here is minus 1 by x, so you have integrating factor is 1 upon x. So once you get the integrating factor, multiply it in this given equation, and the left hand side here, multiply it here, the left hand side will be v times of the integrating factor, which is equal to this integral of q into integrating factor plus some constant c. And from there, reduce the left hand side will be v by x equal to, here you have log of minus log x plus c, and instead of v you replace it by 1 upon y to get the required solution of the given differential equation dy dx plus y upon x equal to x square. I hope it is clear. The rest of the problem, the same method, only we apply, you see it.